Welcome to the Curves and Surfaces tutorial. In this tutorial we discuss photography requirements for curves, basic marking and referencing of curves, editing and manipulation of curves, cylinder marking, surfaces of revolution, and advanced surfacing with lofts. The Curve and Surfaces tutorial will use 3 separate project examples to demonstrate how to use the advanced NURBS curves and surfaces tools. The results of the 3 projects are displayed here. The first project that we will go through is shown at the top left. This is a purposely simplified project with various curve shapes drawn on a piece of paper. We will model these shapes in PhotoModeler to demonstrate the basics of using the curve tools. The 3D viewer shows the resulting open and closed curves. The next project is a model of the desk lamp, which consists completely of curved shapes. This project makes use of curves and surfaces of revolution to create a complete model, as shown in the 3D viewer. The third project is a more advanced project where we model a clock radio. This project uses a number of curve and surface elements. The 3D viewer shows the detailed wireframe model. We start this segment by opening the project called Start.pmr from the Intro subfolder in the Curves Surfaces folder. This is a simplified project that will demonstrate the correct way of marking and referencing curves. This will prepare us for later segments when we start modeling curves on real objects. We have the project open with the 4 photos tiled. The photos show a piece of paper with a number of curves drawn on it. These various curves demonstrate some of the variety of curves that PhotoModeler is able to model. PhotoModeler creates NURBS curves, which stand for Non-Uniform Rational B-Splines. NURBS are the advanced method for defining curves in 3D computer programs. There are 6 base points that have been marked and referenced already. We can see that the photos are already oriented. Photos must be oriented and oriented well before curves can be calculated in a project. It is very important to have the proper photographs if you want high-quality curves. We will explain using this curve here. You start marking a curve using your 2 best photographs. You look at the main axis of the curve, which in this case is horizontal. Then you look for another photograph that is rotated around this axis. In this project, photographs number 1 and 3 have the best rotation about the curve's horizontal axis. If we look at photographs number 2 and 4, we can see that the axis of the curve is vertical, and the position of the camera has changed vertically. These photos will not work well for this curve. We will demonstrate this again later. We zoom in on the curves in photos 1 and 3. We drag the edges of the photo windows so we have a full view of the curves. And then zoom in again. There are 2 types of curves in PhotoModeler, open curves and closed curves. A closed curve is one where the ends join. An open curve has to share a common point across all the photos it is referenced on. Using the point tool, we mark a point at the start of the curve in both photos. We select both points using Shift Select. Then we reference using the Quick Reference tool. The 2 points are referenced, and we can begin marking the curve. We click the Mark Curves tool on the toolbar. The cursor changes to curve mode, and we click on the point at the beginning of the curve. We then move along the curve, clicking down to mark points along the shape of the object. The Curve tool joins the points with a cubic curve. When we reach the end, we right-click and choose End Curve. We repeat the steps for the curve on photo 3. Curves must be referenced before they become 3D. We use Select and Shift to select the curves and click the Quick Reference tool. Now if we select a curve, the status bar displays some information. It tells us it is 3D and appears on photos 1 and 3. We will check its 3D shape in the 3D viewer. We open a view with points, lines, and curves turned on. We click OK and Maximize. We study the model and we see that the curve has the 3D shape we expect. We minimize the 3D viewer. Next, we will describe how to edit a curve. If you had marked a curve then found that the curve did not solve correctly, You would take a closer look at the marked points along the curve to see if they were placed accurately. Curve point positions can be adjusted at any time. Using Select, we select this point in the middle of the curve and drag it to a new position. If the curve is already referenced, the curve's 3D shape will recompute after the point is dropped in its new position. If you find that you do not have enough points marked in the curve to accurately capture the shape, you can add points to a current curve. We click the Mark Curves tool, position the cursor close to the curve, right-click and choose Insert Point in Curve. The cursor then attaches to the curve and we choose a position to mark the new point. You can also remove a point from a curve if you feel it is contributing poorly to the curve. This can be done in two ways. If you are in curve mode, move the cursor over the point, right-click, and choose Remove Point from Curve. If you are in select mode, you can select the curve point and press the Delete key. As you see in this case, deleting the points results in poor coverage of the shape of the curve. We reinsert points for a better curve. Similar to other photomodeler objects, curves require accurate marking in order to produce good results. The curve should follow the shape of the object closely. If it is off, as we demonstrate here, then the 3D result will be poor. You may find that the curves you are marking on your object are not as distinct as the ones shown here. If marking them requires a bit of guessing, try to mark as precisely as possible and then adjust them later to improve the 3D curve shape. There are also some curve properties that help improve curve shape. We move the curve point back into its proper position. Next, we open all 4 photos and select Window Tile and Window Zoom to fit all. We will next mark this curve here, which is positioned at about 90 degrees to the curve we just marked. We will first determine which photos are the best ones to use for marking and referencing. Photos 1 and 3 were the best choices for the first curve. For this next curve, the major axis is in a vertical direction. But photos 1 and 3 are not rotated horizontally around this curve, so they are not a good pair for marking and referencing. We can check this by using the reference helper line or epipolar line. We click Reference Mode with photo 1 as the source and photo 3 as the destination. We press the plus key to zoom in. We click Mark on Source Photo and mark a point on the curve in photo 1. We move our cursor into the destination window and the epipolar line appears. The line appears almost parallel to the curve. This is an indicator that this pair of photos would not generate a good 3D result. What we want to see is the epipolar line being closer to perpendicular to the curve. For example, on the curve we just marked, if we marked a new point close to that curve, then move over to the destination window, the epipolar line is almost perpendicular to the curve and intersects sharply. This indicates a good set of photos for marking this curve. A better pair of photographs for the new curve is photos 2 and 4. We change the source photo to photo 2 and the destination to photo 4. We press the plus key to zoom in on the curves in both photos. We mark a point near the curve on photo 2 and move the cursor over to photo 4. We can see that the epipolar line is perpendicular to the curve. This confirms this pair of photos can be used to mark and reference the curve. While we are in this mode, we will mark the point at the beginning of the curve and reference them across the photos. We then go in Mark Curves mode and mark the curves. We will stay at this zoom setting, even though we may not be marking very accurately. We will next adjust the curve marks. It can sometimes be easier to pan within the Alt Zoom window for points that are close together. We adjust the curve points on both photos. In this section, we are having trouble getting the curve to properly follow the shape. We need to insert a point. We go into Mark Curves mode, then right-click over this section and insert a point. This gives the curve more flexibility in its shape. We click Tile and Zoom to fit all. We select the new curve in Photos 2 and 4 and quick reference them. We reopen the 3D Viewer window maximize, and review the new curve. We can see both our curves in 3D. We maximize Photo 1 and zoom in on the left side. When curves have more complex shapes and no major axis, then more photographs may be needed from more angles. A circle has no major axis around which photographs can be taken. If we use the Edge tool to draw some temporary lines, we can see that the circle's curved lines point in all directions. Closed curves tend to work slightly better than open curves in photographs with weak angles. The proper way to handle closed curves is to reference them across 3 or more photographs. You need 2 photographs that rotate around this horizontal tangent direction and 2 that rotate around this vertical tangent direction. Often with a closed curve, you would first try referencing across 2 photos and check the results. The third photo would be referenced to repair or improve weak sections of the curve. We delete the temporary edges we drew. Next, we will mark the closed curve. With a closed curve, you do not need to have a common starting point across your curves on the photos. We just start marking anywhere along the curve and mark points at regular intervals. We end the closed curve by clicking on the beginning point. This is how a closed curve is defined in PhotoModeler, when the first and last point are the same. When the curve closes, it changes the shape to take into account that the curve is closed. You may often find that closed curves will need to be adjusted after they are marked. Next, we open Photo 2 and zoom in on the circle. We mark the circle using the Curve tool. We then use the Select tool to adjust the points for a better fit. Similar to open curves, you can insert points into a closed curve if you feel it will improve the shape. We reactivate the Curve tool, right-click over the curve and insert points. We do a few more adjustments. We open a 3D viewer with curves turned on and select Window, Tile, and Zoom to fit all. We Shift select the closed curves on Photos 1 and 2. We click Quick Reference and the circle appears in the 3D viewer. Even though we only referenced it across 2 photos, due to the nature of closed curves, we still got a good 3D result. We maximize the 3D viewer. We select the closed curve, right-click, and choose Properties of Selected. This brings up the Properties dialog. It tells us it is curve ID number 6 and that it is a closed curve. We have some options. In the Curve Is section, we choose the Circle option. This tells PhotoModel that the selected curve is a perfect circle. Circles are planar, so this option is automatically chosen. When we click OK, PhotoModel recalculates the closed curve, so it becomes a perfect circle. We select one of the open curves, right-click, and choose Properties of Selected. It tells us its ID number and that it is an open curve. In the Curve Is section, we cannot change it to a circle as the curve is defined as an open curve. We can make it planar. This can sometimes overcome weaknesses in a curve. We can also change how the curve is fit through the 3D data set to make it smoother. The higher the number that is entered, the smoother the curve will appear to be. This does not mean the accuracy will be better. We click OK to apply the planar setting. We review in the 3D viewer, and then click Reset. This curve was strong to begin with, so the planar option does not really add much in this case. We opened this segment with a project called CurvePoints.pmr from the Intro subfolder in the Curves Surfaces folder. This project has some additional curves added. We have photos 2 and 4 open and tiled. We have marked this complex curve on photo 2, and the beginning point has been also marked on photo 4. In this segment, we will look at the effects of point spacing on curves. We maximize photo 4, then zoom in on the curve. We then click the Curve tool and start marking some points along the curve. When a curve has a sharp direction change in it, more curve points should be placed along that section. As it starts to straighten out, you can place the points farther apart. We use the scroll bars to see the rest of the curve and continue marking. We space out the points a bit on this section. Then increase the point density in the sharp portion of the curve. This next stretch is flatter, and we can space out the points again until we reach this extremely sharp curved section. We then again mark points closer together. We finish the curve with a right-click and End Curve. We tile and zoom to fit the two photo windows. We select the curves using Select and Shift and quick reference them. We then reopen our 3D viewer window and see the curves that have been generated. We have the two simple curves, a closed curve, and this new complex curve. This completes the introduction of curves using this simple curve project. We have learned how to determine which photographs are suitable for marking curves, and we know how to properly generate open curves, closed curves, and complex curves. We can now move on to a project involving a real-world object. In this project, we will model a desk lamp. We open the Start.pmr project in the Lamp subfolder in the Curves Surfaces folder. The project has been set up with points around the base of the lamp. They were marked with the automatic marker and then referenced. The photos have been oriented. We can see the oriented camera stations and the points in the 3D viewer. We minimize the 3D viewer. We will start by generating one curve on the light bulb and then generate a cylinder on the lamp's post. Finally, we will use some advanced surfacing techniques called surfaces of revolution. We need to zoom in on the light bulb in the photos. We right-click and choose Zoom 1:1 on both photos. We use the scroll bars to navigate to the bulb. We see the curved line that has been drawn on the light bulb. Using the Point tool, we mark a point at the beginning of the curve in photo 1, just like we did on the curves in the introduction segment. We then select it and click Reference Mode. The epipolar line appears as we move our cursor over photo 2. We use it to help us mark the point. We then click the Curve tool and start marking the curved line on photo 1. We right-click and End Curve, then mark the same curve on photo 2. We end the curve and click the Select tool from the toolbar. We then use the Alt key zoom to look for points that need adjustment. The points on photo 1 curve look good, and we only need to adjust one point. We adjust a few of the points on the curve in photo 2. Next, we select the curves using Shift Select and quick reference them. We then open the 3D Viewer window and drag the window size. In Options, we turn off camera stations, click OK, then Reset. We rotate to review the model so far. We can see the 3D curve line modeled on the light bulb. We minimize the 3D viewer. We will continue modeling by using the Line tool to mark some data. We select the Line tool, move the cursor to this area, and click Alt Zoom. We have added some markers here to help us find these points. We mark the marker points, then another point at this edge, then we scroll down and mark a point at the bottom edge, and a final point towards the base edge. We mark similar points on photo 2, using Alt Zoom to help us mark more accurately. At the base edge here on photo 1, there is a small curved section. We use the Curve tool to mark the curves on both photos. We use the Alt Zoom to mark the curve points accurately along the curve shape. We try to mark the points close together as this curve has some sharp direction changes. We end the curve. Next, we will reference the new points and curves. We click Reference from the toolbar. We scroll up towards the points at the top. While in reference mode, we select the point. Move the cursor over to the destination window, scroll the photo, and use the epipolar line to help us reference the correct point. We reference the remaining new points. We use the scroll bars to help us navigate on the photos. Next, we select the curve, zooming in so we can properly select it, and reference it to photo 2. We then reopen the 3D viewer and review the model. We see we have a profile of the lamp. The goal of this project is to create a surface model of the lamp. We minimize the 3D viewer window, then zoom out on photo 1. The lamp shape is best described as circularly symmetric. For a shape like this, the surface of revolution is a proper tool for defining its surface. Surface of revolution requires a central axis to revolve the profile curves around. The central axis here would be the center of the lamp's wooden post. This line that we created is on the outside of the post and is not suitable as a central axis. To get the central axis, we will use the Cylinder tool. We zoom in for a closer view of the post. We click the Cylinder tool on the toolbar. Our cursor changes to Cylinder mode. We mark the cylinder by clicking a point at the silhouette edge on the left top side, then move the cursor down and mark the bottom. This completes one side of the cylinder. We then repeat and mark the right side of the cylinder. We can use Alt Zoom for a closer view. When complete, we can see the cylinder mark of two edges with a joining line in the middle. We mark the cylinder on Photo 2 as well. We press the minus key to zoom out. Cylinder marking is discussed in more detail in another tutorial. Cylinders also need to be referenced. We use Select and Shift to select the cylinders, and then quick reference them. We then select a cylinder and view some information about the calculated cylinder in the status bar. We open a 3D viewer and turn on Cylinders. We rotate the model and view the 3D cylinder shape that represents the center posts of the lamp. We can use the cylinder as a central axis for our surface of revolution. Surface modes can be more complex than some other photo modeler tools, especially since the various surface models are each used differently. To help us use this tool, we right-click over the toolbar and choose the instruction bar. This places a text bar at the bottom of the screen which will display simplified instructions that reflect the current state and mode of the program. We will also open a surface toolbar by right-clicking over the toolbar. We place the toolbar on the right side of the screen. We maximize the 3D viewer. We click the Surface Revolution tool, and our cursor changes to this mode. The instruction bar tells us to select a curve, edge, or line as the profile curve. This profile of the bulb is our profile curve, so we select it. The instruction bar then tells us to select a cylinder, edge, or line as the axis of revolution. In the case of a cylinder, its center axis is used as the axis for the surface of revolution. We select the cylinder. In the 3D viewer options, we turn on Surfaces and view the surface that was created on the bulb. The surface appears dark, indicating the surface is inside out. We can easily change this using the Flip Surface tool. We press the button from the toolbar and it flips the most recently created surface. We review the model and see our light bulb with its surface of revolution, generated from the profile curve and axis of revolution. While we are still in revolution mode, we select this line as the profile line, then click the cylinder. The surface is created and we click the Flip Surface button to correct the surface. We repeat steps for this other line. On the lamp base, we select this line, then click the cylinder. Lastly, we select the curve as the profile curve, then select the cylinder, and the surfaces are created. In the 3D viewer options, we turn off curves and lines, leaving only surfaces and cylinders on, and click OK. We review our shaded model. We have created an advanced surface model using the Surfaces of Revolution tool, which uses a profile line or curve and an axis of revolution to generate surfaces. We start this segment by opening the new Photos.pmr project from the LAMP subfolder in the Curved Surfaces folder. This project continues the project from the last segment. There are two more photographs added, these ones with the lampshade included. These photos are taken from different sides of the lamp as well. These points have been marked and referenced already, and the photos have been oriented. We are going to use these photos to add another surface of revolution. We will mark a line along the seam in the lampshade. We zoom in on photos 3 and 4. And we can see the seam running from top to bottom. We mark a point at the top in each photo using the Point tool. We then select and Shift and click Quick Reference. We repeat these steps and mark a point at the bottom of the seam. The seam is a bit difficult to see, but if we follow the crease down, we can mark the point fairly accurately. We select the points and quick reference them. We then use the Line tool to connect the points with lines. We open a 3D viewer with lines, surfaces, cylinders, and curves turned on. We review the model. And can see the line that has been added along the lampshade. We click Surface of Revolution Mode and follow the instructions in the instruction bar. We select the profile line and then the axis of revolution. The lampshade surface appears. We click the Flip Surfaces button and review a full shaded 3D model of the lamp. We open the Done.pmr project from the Lamp subfolder in the Curved Surfaces folder. We have a 3D viewer open and photos 1 and 4 opened. In the 3D viewer, photo textures have been added to the base of the lamp. We can see the wooden sections that were mapped onto the model for a realistic result. We have projected cylinders and surfaces onto the photographs. We can see the lamp overlaid on the top of the photographs. If we adjust the transparency in the Settings tab so that it is clearer, we can see the post and light bulb behind the shade in Photo 1. In the Projections tab, we turn off cylinders and surfaces so we can view our photographs. We have added a layer to the project. The lampshade has been placed in its own layer, called Shade. We turn on all the items in the Mark tab so we can see all the data we have marked in the photographs. In the 3D viewer options, we turn off the shade layer, and we can view the base and post of the lamp. In the 3D viewer options, we turn the shade layer back on and change the surface settings so the shaded option is chosen. The result is a realistic looking 3D model. The shape of the model matches the lamp in real life, and the model can now be exported to graphics or CAD programs for further work. We have now completed the lamp model. We use the Surface of Revolution tool to create the surfaces using profile lines and curves, and the cylinder as the axis of revolution. In these next segments, we will continue to use the Curve and Surfaces tools to complete a model of a clock radio. We will use a new type of surface called lofts, and we will use the boundary patch which was introduced in the basics tutorial. We start the project by opening the Start.pmr project from the Clock Radio subfolder in the Curved Surfaces folder. The project has 7 photos. We have 3 photos and a 3D viewer open. A number of points have already been marked and referenced, and the photos have been oriented. A few points and lines on the outline of the clock radio have been marked and referenced as well, but no curves or surfaces have been added yet. We review the 3D data in the 3D viewer. In these next segments, we will continue to use the Curve and Surfaces tools to complete a model of a clock radio. We will use a new type of surface called lofts, and we will use the boundary patch which was introduced in the basics tutorial. We start the project by opening the Start.pmr project from the Clock Radio subfolder in the Curved Surfaces folder. The project has 7 photos. We have 3 photos and a 3D viewer open. A number of points have already been marked and referenced, and the photos have been oriented. A few points and lines on the outline of the clock radio have been marked and referenced as well, but no curves or surfaces have been added yet. We review the 3D data in the 3D viewer. We close the 3D viewer and Photo 7. Tile photos 1 and 2 and select Zoom to fit all. Next, we will mark some curves on the base area of the clock radio. We use Zoom Photo Area for a closer look on both photos. We take a look at the curved features in this section on the side of the clock radio. This curve lies along the horizontal axis. To reference this curve, we need photographs with vertical separation. If we look at Photo 2, we can see that it is rotated relative to Photo 1 about the curve's major axis. Photo 1 is taken at a view that is close to straight on, while Photo 2 is taken from a higher elevation looking down. The angles here are not perfect, and that will affect the accuracy and appearance of the curve, but given the constraints of the shape of the object and the targets that we wanted to use, there were some limitations to the photographs that we were able to take. This is a typical situation, and you may run into similar scenarios when modeling real-world scenes and objects. We select the Curve tool and start at this point, which has already been marked and referenced across the two photos. We click down, then continue to mark the curve. We repeat on photo 2. We then select the two curves and click Quick Reference. Next, we will model this curve section on the base starting at this marked point. This curve is more complex, so we use Alt-Zoom and mark more densely in this section. Then spread the points out along the middle section, then more densely towards the end. We click on this marked point at the end, then right-click and end the curve. We repeat the steps on photo 2. We will model the base with two separate curves. We could have modeled it with one closed curve, but we have better surfacing options when using two disjoint curves rather than one closed curve. With a single closed surface, the only surfacing option is to use path mode. The loft surface mode can be used with the two curves, and it offers a more accurate NURBS form. We start at the marked point to mark the separate curve. When we click on the point using our normal left mouse button, a menu appears. It recognizes that this point has a curve already attached to it, and provides us some options. It asks us whether we want to extend the current curve or whether we want a new curve starting at the selected point. We choose the New Curve option, as we want two separate curves. We then continue modeling the curve, keeping in mind to use proper spacing between curve points. We repeat the steps on photo 2. We then use Alt-Zoom and Select to adjust the point position so the curve has an accurate fit. Many of the points are well positioned, but there are a few that need to be adjusted. We check the points on photo 2 as well. We reference our new curves using Quick Reference. We then open a 3D viewer and make sure curves are turned on. We review the model in the 3D viewer. And we can see the three new curves we just created. We close the 3D viewer and select Window Zoom to fit all. The next section we want to model is the curve section along the back. The curve lies mostly in a vertical direction, so the current pair of open photos is not a good set to work with. We need two photos that have a horizontal separation. Photo 3 has an appropriate horizontal rotation for use in referencing this curve to either photo 1 or 2. We will choose photos 2 and 3 as the set for modeling this next curve. We close photo 1 and select Window Tile. On photo 2, we zoom in on the curved section. We click the Curve tool and start by selecting the beginning points at the lower end of the curved section. We get the Options pop-up menu again, and we choose New Curve. We mark the curve up the back of the clock radio. We right-click and choose End Curve. We zoom in on photo 3, click the Curves tool, and add a new curve. We then select the curves and quick reference them. We use Alt-Zoom and adjust the curve points where necessary. Even minor adjustments can have a positive effect on a curve. We open a 3D viewer window and quickly review the curves. We can see our newly marked curve. We close the 3D viewer. We want to add a surface to this section, but all we have is the two curves. There are a couple of ways to do this. The boundary patch mode can create a surface using 3 or 4 curves. We only have marked 2 curves, but this third curve between these 2 points is implicit, so we are able to use a boundary patch. We can also use the loft. We right-click over the toolbar and turn on the instruction bar. We click the Loft tool on the Surfaces toolbar, and our cursor changes to Loft mode. If we look at the instruction bar, it tells us to select a curve, edge, or line at the start of the loft surface. We will do this in a 3D viewer window. We open the 3D viewer window and drag the window size. We rotate the model then select this curve in the 3D viewer. The instruction bar now tells us to select another curve to continue lofting. We select the vertical curve. We can see by the appearance of the cursor that lofting is designed for use with multiple curves. We are using 2 curves, which is acceptable, but to finish the curve we have to tell the program we are done. We click the Finish button on the Surfaces toolbar. We can also right-click and choose Finish Surface. The surface is dark, indicating it is backwards, so we click the Flip Surfaces button. If we select the surface, it tells us some information. We can see that the surface is a 3D object, so it has computed successfully. We minimize the 3D viewer. Next, we will mark the semicircle curve on the side of the clock radio. Because it is a half circle, it has sections which are horizontal and sections that are vertical, making it a bit more difficult to determine which set of photos to use. In this case, we will use photos 1, 2, and 3 to achieve the best results. We click the Curve tool and start marking a curve on photo 2. We begin at this marked point, then mark around the half circle. We use Alt-Zoom for accurate marking. When we arrive towards this area, we zoom in and mark points closer together, then continue down and end the curve at this point near the bottom. We mark the same curve in photo 3. We use the Control key Pan tool to help navigate on the photo. We end the curve. Next, we will check our curve points. We click the plus key to zoom in on the photo. We then use the Control key and right mouse to pan, and the scroll bars to navigate the photo. We examine the points to see if adjustment is needed. We make some minor adjustments in this area. We use the plus key to zoom in on photo 3. We use the Control key right mouse to pan the photo and search for points needing improvement. It is very important that curves match up as closely as possible across the photographs. We zoom out for a view of the curves, then select the curves and reference them. We open the 3D Viewer window to check the initial results of this curve. We turn off surfaces so we can see the curves. We rotate for a better view. The shape of the curve appears to be correct. Because of the nature of its shape, it will need to be strengthened by marking and referencing the curve on the third photo, Photo 1. Photo 1 has a rotation about the horizontal curve section, and that should help strengthen the curve. We zoom in on the curved area. We click the Curve tool and start marking the curve. We use the Alt key zoom for better accuracy. We end the curve. If necessary, you can use Alt Zoom to adjust the points. We then select Window Tile and Window Zoom to fit all. We select the curve in Photo 1 and Photo 2. And click Quick Reference. The curve is now referenced across 3 photos that should have reasonable rotation about the horizontal and vertical axes. We can see in the 3D viewer that the shape looks stronger now that the third photo has contributed data that allows the program to compute the curve correctly. We start this segment with the More Curves.pmr project found in the Clock Radio subfolder in the Curves Surfaces folder. The project has some additional curves. We have added similar curves to the other side of the clock radio. We open a 3D viewer with lines, curves, and surfaces turned on, click OK, and maximize. We have only marked the one surface so far, but we will create some more in this tutorial. We want to create a surface across these bottom curves. We click the Loft tool and select the 2 curves. Then right-click and choose Finish Surface. We review in the 3D viewer and see the new surface that covers the bottom of the radio. Next, we select the 2 top curves on the bottom section and create a loft surface. We click the Flip Surface button. The order in which the curves are drawn and selected determines which way the surfaces will appear, and in some cases the surfaces appear backwards. The Flip Surface tool is very convenient for correcting this. Next, we will create a number of other loft surfaces. We create one on the side between these 2 curves on the side of the bottom area. We finish the surface and click the Flip Surface button. We rotate to the other side and create a loft between these 2 curves. We have now modeled the base area completely with curves and surfaces. Next, we will select the 2 curves covering the upper sides using the Loft tool. We click Finish Surface, and it creates a large surface that covers the upper back side of the object. We can also create lofts between lines and curves. We select this line and this curve on the side of the radio, and click Finish Surface. We flip the surface. As we review this side of the surface, we can see a problem in that some sections of the model are not covered by surfaces. This surface, which is created from these two curves, does not extend all the way to the front. This is because this curve ends at this location, and the surface that we use implies the third edge by assuming a straight line between these 2 points. There's a trick we can use to fix this. We open the photos that this curve is marked on, photos 1 and 3. We zoom in on the top area in both photos. The trick is to extend the curve even though we can't actually see further along the curve, but still keep the same shape of the curve. We click the Curve tool and select this endpoint on photo 1, and this time we choose to extend the curve from a selected point. What we want to do is extend the curve following the existing curve line and place it deep into the plastic housing. We end the curve. We do the same on photo 3. We choose to extend the curve and place the curve point so it follows the existing curve line. The curves are already referenced, so the 3D position of the extension will be automatically computed. We look at the 3D viewer and study the results. The surface now extends further across the side of the radio. If we delete this surface, we can see that the newly extended surfaces provide better coverage of this section. Even though we are guessing the endpoint of the curve in this section, this is still acceptable modeling given the limitations of our photographs. The extended curve still produces a good resulting surface and a more complete model. We start this segment with a Done.PMR project found in the Clock Radio subfolder in the Curved Surfaces folder. This is a more complete model with even further detail added. We have the 4 photos open and tiled, displaying the marked and referenced lines and curves. We open a 3D viewer with only lines and curves turned on. We rotate the model and review the lines and curves. We have to compensate for some of the limitations that have affected the quality of the curve. The photographs are acceptable but not ideal for marking strong curves. Some of the curves on the object are not very distinct and therefore were difficult to see and mark accurately. This has resulted in some problems. The curves look good from the profile view but are uneven in their side view. To compensate for this, we have forced the curves to be planar. We select a curve, right-click, and choose Properties of Selected. The Curve Properties dialog appears and we can see that the planar option has been checked. This means that any curve that does not lie straight can be made to fit on a plane. This will often correct curves which need some minor improvements. Naturally, this is only acceptable if the curves are planar on the real object. We close the Properties dialog. Next, we will review the surfaces. We click Options and turn on Surfaces Only. We use the viewer controls to review the completed model. We have added boundary patch surfaces to the sections around the front of the clock radio. On the back side, we have used the Loft tool to create additional surfaces. In Options, we will view the model as a wireframe. We choose Wireframe from the Surfaces option drop-down list, and the wireframe model appears. It is a dense wireframe model consisting of triangles that have been created from the NURBS surfaces. This view is similar to the model you would get if you exported the model in its triangulated form. For example, we select File, Export Model. In the Export Type drop-down list, we choose Rhino. This format gives us the option to export the surfaces as triangles. If we chose this method when exporting, the model we would see once imported into Rhino would appear similar to the wireframe model seen in the 3D viewer. For formats that accept NURBS surfaces such as Rhino, you can export the surfaces directly as NURBS. We hit Cancel to exit the export dialog. Our last review is to look at the model with textures added. We click Options and choose Fast Textures. We use Fast Textures first to look at the initial quality of the textures. We view with quality textures later. We rotate the model, and the textures look good. If we view the bottom, we can see that this area is a solid color and not a texture. There are no photographs that capture the bottom side of the clock radio, so this surface is assigned a color that is defined in the Advanced Materials properties. We click Materials, choose Surface Default, and Advanced Materials Properties. In the Photo Texture Settings section, there is a grayish color defined here. This setting tells PhotoModel that when a surface does not point towards any photographs, it will assign this color to the surface instead. This color can be changed to any color of your choosing. We close the Materials dialogs. If we review the model some more, we can see that most of the model was able to use textures. There are a number of other surfacing methods which we have not demonstrated. We will briefly describe them. Path mode is used when you have more than 4 boundaries or when you have a closed curve. This creates a triangulated surface. Path mode does have a NURBS form, but creating NURBS from arbitrary paths can lead to lower quality results. Triangle mode creates triangular surfaces by clicking on 3 points. This method can be used for quickly surfacing objects that have triangulated sections. The loft mode was explained in this tutorial. The sweep mode is a surface creation tool for sweeping a profile curve along a rail curve. Sweep mode is shown in the Other Tools tutorial. The revolution mode was described in detail in this tutorial, and the boundary patch mode was introduced in the Getting Started tutorial. The cone mode allows you to select a point at an open or closed curve and generate a cone or a partial cone. The point cloud and automatic surfacing triangulation methods are shown in the Auto Tools tutorial. These other various functions assist in creating and editing your surfaces. This section has some tools for what is called surface trimming. This allows you to take curved loops, project them onto a surface, and cut the outside or create holes in the surface. This concludes the Curves and Surfaces tutorial. We have worked through 3 projects: the Simple Curves on Paper project, the Lamp project, and the Clock Radio project. The topics we discussed were proper photograph rotation required for curves, basic marking and referencing of curves, editing and manipulation of curves, modeling complex curves, cylinder marking, surfaces of revolution, and advanced surfacing with lofts.